Hey everybody, today is going to be focused on what we call nth roots. So you guys have always worked with square roots, and now we're going to be talking about roots that have higher exponents other than 2. And to start off, I just went through a list here of an example using exponents and how we can word it using what we call our nth roots. The first one says 2 squared equals 4. Hopefully you know that. And if we were going to say that in terms of a root, we would say that 2 is the square root of 4. Okay? The same thing applies. I increased the exponent, so 2 to the third, we would get 8. So we could word that in terms of roots by saying 2 is the cube root of 8. All right? And then 2 to the fourth gets us 16. And again, 2 would be the fourth root of 16. So notice every time I'm increasing my exponent, I am changing the number of root. So it'd be a square root, cube root, fourth root. It could be eighth root. Just depends on what you're working with. All right? Now, in more of a general term, I went ahead and typed this here. This is for any number, and this concept can work for anything. We'd say b to the n equals a, and so we could rewrite that or word that as b is the nth root of a, and if we were going to write this in terms of roots. Now, we can go back and forth between the notation. So if I told you originally b to the n is equal to a, then the wording where I said b was the nth root of a could be written like this, that the nth root of a is equal to b. So these are saying the same things, just written two different ways. So b to the n will get me a, or I could say the nth root of a equals b. So interchanging the notation, this is the exponential form. So this is exponents, and this is with radicals. So that's the big difference, is just the notation. Later we're going to talk about how we can switch back and forth from those quite a bit. Now, there are a few things in this notation that I want to make sure you understand. The n we call the index, and so the index just comes from the exponent, right? So whatever exponent you had, that's the number that's going to go there. The radical sign there is just called the radical sign. And then the number underneath, so a, is called the radicand. So if I ever say, what's the radicand? I'm looking for the number or the letters that are underneath the radical symbol. All right, and that's it. So the index and the radicand, and then obviously the radical sign. Those are the three main parts that you need to make sure you know. Now, when we start solving our roots, our rational roots, we're going to be dealing with multiple types of answers. So the first thing you need to know is that a principal root is just the non-negative answer. For example, I could say, what's the square root of 25? Well, the answer, the non-negative answer, would just be 5. So 5 would be the principal root. Okay. However, if I stuck a negative out in front, so negative 25, square root of 25, my answer would become negative 5, because the square root of 25 is 5, but then I make it negative. So I'm changing my answer based on the positive or negative sign I put out in front. And then I could ask you, well, what's the answer to plus or minus root 25? Well, if I do that, I'm going to get plus or minus 5. So notice just the one answer, 5, that's our principal root, but then I can have variations of my answer based on the signs that are out in front. So if it doesn't have a symbol out in front, just assume that you're going to be looking for the positive number. All right, now we're going to take this a step further. This chart is from your book. It would be really good to make sure you have in your notes. Basically, it just tells you the breakdown of the types of answers that you could get. So there are two types of index numbers: when the index or the degree is even, or when it's odd. And for each scenario, we have multiple sub cases. If my index is even, then my number underneath could either be bigger than 0, less than 0, or equal to 0. And so what it does is it tells you what kind of answers you could find. So, for example, in this first case, if my index is even and I have a number greater than 0 underneath, so like that, the fourth root of 16, then my answer is going to have a positive answer and a negative answer. All right, so you're going to get a plus or minus answer out. And it's just telling you here that your positive root would be your principal root. Okay, so this would get you 2 answers. But then I could have something where it's the fourth root of negative 16. So that would be when my a is less than 0. Well, you can't have any exponent to a fourth power that's going to get you a negative number. And if that doesn't make sense, I could write it this way. I could write what to the fourth gets us negative 16. Well, there is no number to an even power that can get you a negative answer. So this means there are no real roots. That means you're going to have imaginary answers. Okay? And then lastly, if you had the fourth root of 0, anything to the fourth power to get you 0 is just going to be 0. So you have one answer and it's just going to be 0 every time. Okay? Now, the same rules apply to our odd index. So in our odd index, if my degree, or sorry, like maybe we have the cube root because 3 is odd. Maybe I have a number bigger than 8 or than 0. So let's say 8. The cube root of 8, I'm only going to have one answer that gets me that. In this case, it's 2, because 2 to the third is the only number that will get me a positive 8 out. I couldn't do negative 2 to the third because that would give me a negative 8. Okay, so you only have one unique solution, and it's going to be positive. If my cube root is negative underneath, then I'm going to get the negative answer out. So odds are more specific than the evens, okay? And then if I have the cube root of a 0, I'm just going to get 0 again. So odds and even degrees, those are going to change the kind of answers that you get out. And you want to make sure you know the kinds of solutions each time. All right, let's go ahead and start with our first example of practicing simplifying these radicals. So the first one I'm going to give you is plus or minus the square root of 16y to the fourth. What you're going to notice in our roots now is that not only are we going to have numbers in our square roots, but we're also, or our roots, but we're also going to have variables, and we're going to practice how we can reduce both of those. Also notice in this, we have a radical sign here, but we don't have a number out in front. If there's no number written out in front, that means that your solution, or that number, is going to be an understood 2. All right, so even if it's not written automatically, it means it would be a 2. I'm going to go ahead and take the square root of everything that is here. So what's the square root of 16? That's going to get us 4. Now, the square root of a variable is a little bit different. When you have exponents, you want to divide the exponent by the index, okay? So in that case, I would have 4 divided by 2, which gets us 2. That means that we're going to have 2y's, so we're going to write y squared. And then this plus or minus out in front, we're just going to stick here, because that means we're going to have two answers, the positive 4y squared and the negative 4y squared. And then we're done. So do the square root of the number first, then deal with the variable second. All right, let's try another one. Here we're going to simplify the square root, or the fifth root, sorry, of 243, a to the 20th, b to the 25th. So again, we're going to start this off by dealing with the number first. So we're going to have the fifth root of 243. Now, if you don't know the fifth root of 243 off the top of your head, what you can do is rewrite this as what to the fifth gets us 243. And then if you need to go to your calculator, you can. And you could go through and test. 2 to the fifth gets us 32. 3 to the fifth would get us 243. So the answer is 3. So that means our answer here is going to have a 3 out in front. And then we can go through and divide our exponents just like we said over here. So the 20, we're going to take 20 divided by 5. That gets us 4. So that means we're going to have an a to the fourth now. And then 25 divided by 5 gets us 5. So we're going to have a to the fifth. And then b to the fifth. Oops. And then we'd be done. And this was an odd exponent, or an odd index. So that means that we would have a positive answer because this was all bigger than 0. So this is our only answer for this solution, and then we'd be done. Let's try one more. Let's say we have the square root of negative 16 x to the fourth y to the 8. So again, there's no number here, so we assume that it's a 2. And now we have to go breaking it down each part. So the square root of 16, negative 16, is there anything that will square to get a negative number? Well, we know that in even powers or even index numbers, there is no real solution for negative numbers. So that means that this has no real solutions. So you could write that. However, we do know that it's going to have an imaginary solution because what's the square root of negative 16? This is from last semester. We know it's going to be a 4 and an I. So we're going to have that imaginary number in there. And then we could go through just like before and deal with the exponents. So 4 divided by 2 is 2. So that means we're going to have an x to the second. And then 8 divided by 2 is 4. So we're going to have y to the fourth. And one thing to keep in mind is that imaginary numbers travel in pairs. I'm going to put that here. So imaginary numbers come in pairs. So that means that if you had 4i x squared y to the fourth, that also means you're automatically going to have negative 4i x squared y to the fourth. So imaginary numbers, you always have to have the positive and the negative of it. Make sure you don't forget that. Okay? So that's basically it for reducing our roots in this particular section. So if you have any questions about what you do with the numbers out in front or what you do with the exponents, make sure you ask me in class and I'll go through a couple examples with you. All right, so that's it for this first video. Thanks for listening.